Hey John, how's it going? We are just going to continue on with chapter 11 stuff. I haven't heard from you in a couple days, so my thought is if you're not feeling well, then you can always just watch these videos whenever you're feeling a little bit better. We have about 5 more chapters that we have to get through before the Regents, and I really feel like you can do this because you're really smart, so hopefully you're watching these. Now we're going to just expand what we talked about yesterday, and we're going to start writing the equation of a sine or cosine graph. And it's really easy. They pretty much give you all the pieces of information that you need, and then you just kind of have to put it together. So let's see, we're going to write the equation for the sine curve, whose period is 2 pi over 3, and whose amplitude is 4. Now the normal setup for the equation of a sine graph is like this. Y is equal to A sine of bx and then, maybe you'd have a plus c in here because that would be your horizontal shift going left and right, and then the plus d would be the vertical shift going up and down. But in this question it doesn't say anything about horizontal or vertical shifts, so it looks to me like I'm not going to have to deal with those. I do have to deal with amplitude, and it tells me that the amplitude in this case is 4, so that's going to be easy. But the only tricky part is we need to figure out what B is. Now B is the frequency. It tells me the number of curves between 0 and 2 pi. But we're only given the information about period. Now if you go back a couple days, I told you that the definition of period is 2 pi over B. So if you are given this equation right here and said that the period of this graph in particular is 2 pi over 3, then obviously what is the B, or what is the frequency in this case? Sorry, that's supposed to be a 3. What's the B? B is equal to 3. Sometimes you're going to see questions that are more complicated than that, and you're going to have to cross multiply and solve for B. But in this case, the B is clearly 3. So this is my final equation. Y is equal to 4 sine of 3x. That's it. That's literally how easy these questions are. I mean, they might get a little bit trickier, but pretty much that's the gist of it. So let's try another one. Write the equation for a sine curve, so we're talking about sine, whose period is 4 pi and whose amplitude is 1. So I know that the amplitude is 1, and I need to figure out what my B is, or what my frequency is. So we're going to do exactly what I said before. I know that period, which is the information that we're given, is 2 pi over B, and they are telling us that the period is 4 pi. Now if I set this up as a fraction, then I can just cross multiply and solve for B. So 2 times 1, I'm going to cross multiply. 2 times 1 gives me 2 pi. And then on the other side we have B for pi. I have a pi on the left and the right hand side of that equation, so I can kind of just get rid of those. So I have 2 is equal to 4b. Divide both sides by 4, and I have b is equal to 1/2. So that's how you would go through and solve that equation. Now I have both pieces of information that I need, and I can write my equation. Y is equal to the 1, or the amplitude is a 1, so it's kind of like we don't ever write 1x. You just kind of like assume that it's a 1 if there's nothing written there. So y is equal to sine x, or sine 1/2 x, because our frequency, or B, is 1/2. Pretty easy, right? Not so hard. Write an equation for the cosine curve, whose period is 2 pi and whose amplitude is 1/2. Now you can set this up and write it out as 2 pi over B is equal to 2 pi, or you can think about it and it says that the period is 2 pi. Well, the period is the amount of space that I need to see one full curve. So this is telling me that I need 2 pi radians to see one full curve. So the frequency, how many curves am I going to see between 0 and 2 pi? Our frequency is just 1, because I'm only going to see one curve right there. Now if that's a little bit hard for you to think about, you can always just do what I did in the last 2 questions and cross multiply, but I think that you could probably understand that question without having to do it. So this is equal to, y is equal to 1/2, the amplitude is 1/2 out front, cosine, and then my B is 1, so I don't really have to write that, cosine of x. Okay? Let's see what else. See, I told you this stuff is really, really easy. Now, this is kind of going in reverse. you're being given an equation, you have to figure out what the amplitude, frequency, period, and range all are. Fantastic. Okay, the amplitude. Amplitude is what is written right out front of the sign. Now here's what's tricky about this equation. Normally we see the part with the sign written first and then something added or subtracted on the end. This one, it's kind of been shifted and the -7 is out front. So don't get confused. I could rewrite this equation as y is equal to 2 sine of 3x minus pi minus 7. And if it's easier for you to see it in that way, then you can just go right ahead and rearrange it like that. Okay, so now my amplitude is a +2. Amplitude is always going to be a positive number anyways. Frequency is the number that's written right next to this x, so my frequency is 3, meaning I'm going to see 3 curves between 0 and 2 pi. Period is 2 pi over b, or 2 pi in this case over 3, because my b is 3. Meaning that's the amount of space that I'm given in order to see one full curve. And then the range. Now remember how the range is the y values. So the range is always the maximum and the minimum. Now the reason why I'm writing it down here is because you can see that it has been shifted. We have a horizontal shift minus pi, meaning it's actually been shifted to the right pi radians, but shifting left and right isn't going to affect the range. It doesn't affect the y-axis. So I can just forget that fact, and then all I have to really look at is that -7. That means that has a vertical shift, so it's actually been shifted down 7 degrees. So what we do in this case is we take a look, we forget about the fact that it got shifted at all. In fact, I can just put this up so that we don't even look at it right now. Forget about the fact that it was shifted. Just look at this equation and say, what was my original maximum and what was my original minimum? My original maximum was a +2. My original minimum was a -2. And I'm getting that information by looking at the amplitude right here. Now you can say, okay, but everything has been shifted down 7. So we're just going to subtract 7 from both of those values. Okay, so +2 minus 7 is a -5, and -2 minus 7 is a -9. So this is my new range. Y is greater than or equal to -9, less than or equal to -5. And then you're going to go ahead and do the exact same thing for the second equation. If you want, you could always pause the video right now, stop, and do it out yourself so that you make sure that you know how to do this on your own. Obviously, I'm not going to just sit here and wait for, the clock to run down while you're technically supposedly doing it. So I'm just going to keep going. My amplitude is always a positive value, so my amplitude is 3. It's the number out front. The frequency is the number that's written right next to the x, so my frequency is 4. Now I'm going to do my period, which is 2 pi over b, or in this case 2 pi over 4. I can simplify that just a little bit and write it as pi over 2 instead. I'm sure that either one of those answers would be acceptable. And then the last part, what was my original maximum, what was my original minimum, and then we can shift that down 1 because I have this vertical shift going down 1 right there at the end. My original max was 3, my original minimum was -3, and I'm getting that information from the amplitude because the amplitude tells you how high and how low that the graph goes. So I'm going to do 3 minus 1, which is equal to 2, and -3 minus 1, which is equal to -4. So my new function, the range, is between -4 and +2. You really need to write it out like this. Or you could always write it out like this with brackets, but you need to have the square brackets indicating the fact that it's less than or equal to, and greater than or equal to. So you could write it like that as well. Okay? Let's do the next page. What transformation would cause the graph of y is equal to cosine x to coincide with the graph of y is equal to sine x? Well, We actually already did this the other day. Remember when I graphed that cosine curve and I graphed the sine curve on the same set of axes, and then you saw that as we shifted it to the left and to the right, the cosine and sine curves kind of lay on top of each other. But we could always just do it one more time so that we could check. So I'm looking at what would cause the graph of cosine to coincide with the graph of sine. So here's what I'm going to do. If I'm going to graph anything for trig functions, I need to make sure that I'm in radians first, and then I'm going to go to y equals. Let's clear out what we have in there already. And then I know that in order to get cosine to look like sine, I'm going to have to shift it left or right, some amount, but I'm not really sure which amount I'm going to go by. Obviously, it's going to either be, pi over 4, which is 45 degrees, pi over 2, which is 90 degrees, maybe pi, which is 180 degrees, one of those values. So what I'm going to do is I'm going to write cosine of x, and then whenever you have a value that is being added inside those parentheses, that's the horizontal shift, left or right. So what about if we add pi over 4, I don't know, and see if that will look like a graph of sine. And if it does, then we're good. Let's just set up our window between 0 and 2 pi. I'm going to make my y minimum -1 and my x minimum +1, just because I didn't mess around with the amplitude of this graph. So let's graph that. So you can see that it's definitely still, it still looks like the cosine curve to me. You can see that it's been shifted just a little bit over to the left, obviously, because we were adding something, so it's going to go to the left. But it doesn't quite look like sine yet. Now remember that sine starts at 0, ends at 0, goes through 0 in the middle. Maybe if we just keep going a little bit more, maybe that'll help. So instead of pi over 4, what about if we do pi over 2, which is 90 degrees? And let's graph that. Starting to look a little bit more like sine, just because of the fact that it starts at 0, ends at 0, goes through 0 in the middle. But what I am noticing is that it goes down the valley first and then up the hill. So that's not just the graph of sine, that's actually negative sine of x. So that tells me that we've been shifting this graph over to the left. Maybe we need to shift it over back to the right, that same amount, and maybe that'll work. So let's change that from x plus pi over 2 to x minus pi over 2. Let's see if that works. Graph. Awesome. Good. That worked. So now starts at 0, ends at 0, goes through 0 in the middle. We're going up the hill first, then down the valley. Awesome. So what was that equation that we just did? Y is equal to cosine of x minus pi over 2. So we shifted cosine to the right 90 degrees and it lied right on top of sine. Awesome. Okay, so that's how you would approach a question like that. You could use your calculator and kind of just experiment with things. Alrighty. And I guess that this is just where Miss Tompkins actually did that out in the class. Okay, now we're going to start doing multiple choice questions where it gives you a couple of pictures and you have to pick the one that represents the equation that's given. Okay, so we have to find the graph that represents the equation 1/2 cosine of x. Now, what I was telling students in class is cosine, you know that cosine starts at its maximum. Okay, so cosine's not going to go through the origin. The only graph that goes through the origin is going to be sine. So if you're looking for cosine, you can automatically cross off this option and you can cross off this option because they go through the origin. That must be a sine curve. Okay, so we're left with this one or that one. I can check to see that the amplitude is 1/2, but both of those graphs, this one goes up to 1/2, down to -1/2, so does this one. So what am I left with? What other piece of information? I can look at the frequency, or the B, and in this case my B, or my frequency, is 1. And that means that between 0 and 2 pi I'm going to see one full cosine curve. So this one I only see half of a cosine curve between 0 and 2 pi. That means that my answer is A. Alright, let me see if I need to stop this. Alright, and I will be right back.